Welcome, everyone. It's Friday. Excited to have Shajay Bhooshan of Zaha Hadid Architects here. I've known Shajay for quite a few years from the world of digital fabrication, and am endlessly fascinated with Zaha Hadid and their very large number of amazing projects. But Shajay, a pleasure to have you. Could you please begin your presentation?
Yeah, thanks so much, Greg. Thanks for the invitation. And yeah, as Greg mentioned, like we've been known each other for quite some time. And my common point of interest is digital fabrication. And of late, like we've also turned our attention to timber. And but the larger topic is digital fabrication and how to design for it. And like, so I'm going to present like our approach at Zaha Hadid Architects. And it's just to present our what we are up to, and like to engage in a conversation and see how maybe we can participate in more of the timber activity that's going on in Northern America, particularly in the US. So that's why I'm calling it digital timber, a ground-up approach, because that's more or less how we initiate any set of research that we do in the company on any topic. So computational design, like that's my background, and I run the computation and design research group at Zaha Hadid Architects. And I'm also doing my PhD at the ETH in Zurich, and that's not related to timber, but it's still related to digital design and fabrication and so on. And I'm also teaching at the Architectural Association Design Research Lab. So in that sense, like I feel very fortunate to have a kind of ringside view of various like kitchens of architectural research profession, yeah, practice and academia. So this and my primary role is indeed as a head of Zaha Code, like and we've had a kind of open mandate to research and evolve tools and markets, etc. Since 2007. And most people might know our if they know our company, they know them from like these kind of large buildings, like the Beijing airport, which is one of the world's largest passenger terminals, attracting a large number of sightseers, not just visitors, every day. And also this other building, like with the world's largest atrium, like where we have to innovate not only digitally, but also legally and building code wise. In that sense, like these buildings, they were completed in 2019. But like a lot of the technological and innovation investments were already made a decade ago, like in, just after the Beijing Olympics, building the networks, building the capacities, etc. And I joined the office around the time these investments were being made. And it kind of opened up like the idea, and also showed me a kind of pathway to realize any kind of interest that people might have in the digital space. And like my interest was centered around creation of geometry from the computer graphics world, and also robots, and particularly industrial robotics as used in the automobile industry. And so like fortunately around the same time as 2007, like there was a seminal book that came out, like almost like a textbook. It was called Architectural Geometry, and it's a kind of growing field that collects geometry-based ways to reason about shape and fabrication and structural performance, etc. So in that sense, it has some similarity with design for manufacturing and assembly, or design for constructability, etc. But the primary research field is called architectural geometry. And We've been invested in that. It's kind of. Oh, yeah. So there is a pre-computer precedent to all architectural geometry, like particularly in these Renaissance buildings of stone masonry, but also timber constructions. So all of these calculations were made purely using geometric rules and calculations using protractors and rulers. And so and that also allowed the architects to kind of focus on the user experience and user interfaces, etc., of the building, less about the procedure of construction and structural calculation, etc. And the same geometric rule systems were encoded in the construction manuals, how to draw some of these curves or shapes in the physical world, and also in the kind of timber joinery, and the instruments even encoded the geometry or geometrical rules. So it's a kind of pre-computer precedent to the architectural geometry. And this is a hugely multidisciplinary field, like that is kind of growing rapidly since 2007. It has a second birth, kind of like it. And it's like everywhere in across the world. It's not restricted to any one single universities, let's say. So in that space, like we started with like a kind of naive interest, like several, like more than 13 years ago, and then since then we've been building research around this topic. And research includes insights, developing the network, supplier network, researcher network, and the talent pools to do these kind of work, and encoding that knowledge into and creating prototypes like these, and developing software code, etc. Um, and we also built like pilot projects using like some of these new ideas and fabrication methods and shape generation methods, etc. Like this gallery for mathematics in the heart of London, the Science Museum of London, which it's a small museum, a small gallery of 1,000 square meters. And before we made the intervention, or since we made the intervention, it's already been visited by a million plus visitors in the first year. And so we feel that that's a good testing ground, or the first pilot, where it rubs against the real messy world of people interacting and so on. And then subsequently, we've also built like a large number of scalable tools, like encoding all of that practice and tacit knowledge and experience into scalable, robust tool sets. And then how it starts interacting with BIM and like VDC, etc., like how to deliver these projects at scale. And so to the point that like we are now as a small team, like Zaha Code, like we're contributing to very large projects, like including this 60,000 seating stadium in China, which will be built in about 3 years, designed and built in 3 years. And that geometry-based thinking permeates all the way to the drawings like our contractual drawings, we are definitely looking at a method statement that involves how to describe the geometry that in such a way it can be recreated by multiple parties. And that's true for the roof or the facade or all the major elements and that permeates, that reasoning permeates all the way down to the detailed drawings and the structure and so on. So there is one major advantage of like geometry-based reasoning, that it permeates like all the way down to the last nut and bolt. And to the point that like all our previous experiments from the first decade, like prototypes, development, research, etc., have gestated into all these buildings. Like the top 2 rows are buildings that currently are on our drawing boards, which we're handling, contributing in this particular year, and the bottom row is like stuff that we had worked on before. And just to give a sense of scale, like since Zaha passed away in 2016, like we were part of only one project that has been completed, but but we're part of 7 or 8 projects that started since she passed away, and you can see that we are genuinely trying to scale up, having started from first principles. So this is the general journey that we hope to achieve, that we start at the architectural geometry, first principle, ground up, and kind of scale them and integrate it with a manufacturing sensibility and so on. So on the left, we have like structure and fabrication aware geometry, things, experiments with robotic and digital fabrication, integrated design engineering fabrication, in the sense of the master builders of the past. And on the right there, there's commercial industrialized ways to deliver modern buildings with the correct industrialized sensibility. So that's what we generally hope, and we've been making, particularly in the material systems related to textiles, cable nets, glass, metal facades, etc. And so, and of late, like we've been in the last 3-4 years, like really paying attention to replicate this journey in other emerging materials and fabrication systems. And one of them, like we are paying close attention to, is robotic hot wire cutting of mold making, and then casting against concrete, like so to develop precast building elements in this way. And other, of course, is 3D concrete printing. And the last one is we're trying to focus on or pay attention to is like, can we replicate this ground-up approach for timber? And so like we've been kind of, maybe I can take pause here if there are questions.
No, I don't see any yet, Shajay.
Okay, great. So as part of like our endeavor to go ground up, like we started with timber exactly the way we started with other things. Like our large part of our exploratory work happens with AA DRL, which is the graduate research course that where we teach, and so we've been exploring this for several more than a decade, like at AADRL, and like in the last 3-4 years we started looking at timber from in a kind of blue sky way, various languages that are possible, like and so on, and how that can be, how that correlates and corresponds to various like production systems, like for one architectural system, like what is the corresponding production or factory layout, etc. And also like just like visualizing some of these and providing like kind of illustratory proof concepts, like and explore like how some of this can translate into to real building work. And then like alongside, like we also like during competition work in Zaha Hadid Architects or actual commission work, we try to show aspirational and design aspirational spaces, and like this all timber stadium that we proposed, which hopefully will get started at some point, or and also frame and promote like the timber aspects in an architectural sense, and in a sense that makes a lot of communicates the value to the client, etc. And this one is in Cambodia, like a kind of museum, and so on. And also we are trying to propose like use value, like not everything needs to be in timber, like, but like kind of integrate timber in the most used spaces in a building, for example, and like focus on like modular construction and existing systems for other things, like in steel and other materials, like and kind of highlight and showcase like make timber part of like the lifestyle, so to speak. And like everything else is standard modular construction, but like places where the client wants to spend money, the public spaces, the kind of co-working, co-living kind of spaces, the event spaces like that we're clearly highlighting. And at the same time, we are also developing a lot of design procedures, like how to design, how to draw these shapes in a convincing way, like, and how to explore the possibilities for designers in a heuristic way, or also in a detailed analysis way. Like, so this is typically part of like our exploratory is like how to draw certain things, right? Like, so we have to come up with procedures that we co-evolve with like the designers in the company, and also like then back up that intuition with numerical analysis, like quick analysis tools, etc., like on the structural performance or material consumption, etc. um, uh, or- and also we are developing like fabrication related network, like with research groups at the Block Research Group, for example, in ETH, with like Bloomer and Lehman, one of the leading manufacturers in Europe at least, and also software developers in McNeil and Epic in general. In particular. So, and alongside, we are also looking at the history of like timber construction and why it fell out of favor in the UK, for example. There was a prolific phase of timber construction, many buildings, and down to like even like detailed like handbooks of like how to calculate these things, so you don't have to generally hire like expensive engineering. Like, so it was a prolific industry in that sense for a while, and then it fell out of fashion, and began to be replaced by not by concrete but by steel, and also like that gives us insight into like perhaps how we can make timber return. I mean, famously, like the British people are not rather averse to timber because of fire reasons. And we're also developing a lot of prototyping exercises, like with students and workshops and generally otherwise. Trying to correlate those physical experiments with like geometric modeling, structural behavior calculations, or and new techniques and tools that are emerging from ETH and UPenn and other places. And so this is like my colleague at the ETH, when he was doing his PhD, he was trying to figure out like how to calculate, axially loaded structures in 3D, which are particularly conducive for timber, because timber is rather good both in compression and tension. And so alongside, we thought like the same tools, like we can utilize and say like there's a fabrication benefit to those structural tools as well, because the shapes that come out of it like exhibit certain properties that makes it easy to create like planar developable shapes, so which can be constructed by bending sheet material, including thin wood, thin ply. And so we alongside then therefore expanding and trying to consider how we might use such things spatially, both in the fat sense and also in the thinner sense, etc. And so now we are in the phase of building a pilot project in timber, like with all of these exploratory aspects, which is what I will talk about for the rest of the presentation. And subsequently, we hope to then build the scalable tools and also build the delivery capacities in collaboration with like all of the industry partners that are already doing extraordinary work in the space of mass timber. Again, I will take pause if there are questions. No. Okay, so so that's our approach to like exploring a topic, is to do graduate student work, graduate research work, and then also aspirational competition images and develop the basic research around geometry creation, understanding, analysis, etc. Until we reach this pilot phase. And so what are the counterparts in industry? Industry is clearly in the mass timber sense, taking a different approach, a complementary approach, but a different one where they're trying to learn from the automobile industry in the scale sense. And they're directly working at the scale of DFMA, building as a product, as service, etc. And this is also has a prehistory in architecture, like this Lustrum house, the idea that like you can create houses or try and create houses with less than 10,000 10,000 parts and so on. And this comes from the automobile industry, like this Volvo, where there are like about 7,000 parts in a car, etc. So, and this is clearly reflected in like attempts by the major players in this space, particularly Google and Katera and others. Like this project, like, so what are the features that they share, all of these efforts? Yeah, first and foremost, they have like design IP that they wish to develop, which and all of these various buildings can be put together with the same kit of parts. That's an idea that almost all of the major efforts share, and this is from the Google. How do you say, the documents that they put out, the Sidebox Live put out for the Toronto exercise they did, like the key site development. So which is a fantastic effort, like to put out all of these information and resources. And also like they share this idea that like, you know, there will be a gigafactory that will develop or manufacture all these parts. And that like there's an integrated supply chain, all of it is considered ahead of time, and also there's like a aspect to the people side of things, the community engagement side of things, which in the case of Toronto they did with in a very traditional means, like round tables, like post-it notes and so on, and it took like a year and a half, etc. And so all of this was very useful information for us when we started looking into how industry is evolving in the mass timber sense. And in the UK, we found that like there's like 1% of the SME firm, 1% of the AEC companies, which is about 1,000 companies of like 1 million companies in the UK. And they're kind of responsible for like about 75 billion pounds worth of annual turnover. And we also then realized that that's why it's attractive to have these 6 features. Like you want to have all of these things integrated so you can tackle this this huge market. I mean, this is perhaps like order of magnitude larger in the US, but but alongside, we also realized that like the other 99%, like of SME firms actually accounting for a sizable market themselves as well. Like, so there's like accounting for about 60% of the UK economy. And like, so we cannot tackle this 99% with the same thinking that like that you can tackle the 1% with. So there is a complementarity here that like we wanted to explore in one of our first pilot projects, which was like this project like on an island off of Honduras. It's called Beabu, and like we were partnering with AKT2, the structural engineers, and Hilton and Moran, the environmental and engineers. So there we found this distinction that we are now trying to make, like the idea of digital timber, which is more on a smaller scale, more architectural geometry oriented, and how we can then later join up with mass timber. So what we try to do is like retain the design IP idea, like how do we develop designs, but nonetheless which are localized and adapted, and architectural geometry based software creation, and instead of a large gigafactory, how we can have microfactory, and instead of community engagement through traditional processes, like how we can use technology enabled user participation. And um, and so starting like with the user participation, like we try to develop designs in such a way that, like, you know, it offers more choice to the users, and they can directly make choices, like using a online user friendly software. So, but that in turn means a significantly lot more work for architects. Like, so we are foregrounding user choice, which means like we need to think about like how to design all these choices, how to convert user choices of picking some pixels into corresponding, you know, output. So this also is very amenable and conducive to computational procedures, right? So this is the only way we could do that, like to go from the left to the right. And so we built this, like, you know, configurator, so to speak, like in Unreal Engine. Like, it's not any CAD platform, but like all our prior experience in creating geometry, then like we are able to quickly port over and adapt to make use of this kind of real-time rendering aspects of Unreal, and offer all of these as real as possible kind of view to the end buyer. And so on, they can choose not only the interior layout, but also where the house can be in a spatial grid, in a 3D grid. So it's unlike a car configurator in that sense. Like, you can literally purchase some voxels and then see the house being calculated within those. And this, like, then highlights a few things, like so this, like, all the buyers, given all the choice, they still restricted themselves to the bookends, and restricted themselves to the higher areas. So, like, you know, and that became obvious. Why? Because they don't want to pay for viewing rights, etc., like that come for free on the bookends. And the other advantage is that we could see like which of the layouts are popular and which are not so popular, etc. And this kind of game interface also became like a tool enough for us to then engage with our engineers. Like, we just take screenshots, and the engineers kind of give feedback as to these are things that we should definitely look at now, once the choices are made, etc. And then also, like, more percolates deeper down into like which specific things can we engineer, how much it's going to cost, etc. And all of this is kind of built upon the same idea of design IP, like creating a variety of spaces and house types and combinations, using a finite kit of parts, right? And that's so, and it's a kit of parts that is specifically designed for the terrain and for the client. And so it's kind of localized to the area. And so this is a kit of parts that came out of this exercise, which and as we said, like, we're also working with the Circular Factory, which is a company formed by the client to import only the robots and work with local timber and local skilled labor. And it's going to be a small micro factory. It's not going to, it's like a small container built on site. And so the main thing is, like, we have made all the changes to the design so that it works with these machines, like the amount of things that they can lift and process, etc. It's not so much that, like, we have to post rationalize something that has to work later. So ahead of time, like, we're kind of considering how to convert raw material into various processes into the house, and how long it takes, and how much effort it takes, etc. So that's where we are at with this project. I mean, we have evolved a bit much further. Like, I can't show much more on it, unfortunately, right now. But we like we have tried to hang on to all the things that Google did right or Sidewalks Lab did right, and modify the things that we thought like necessary to make it work for at a smaller scale, in a startup kind of sense, in a remote part of the world, in a kind of emerging economy side of the world. And so that's how we realized that, like, you know, this approach has additional benefits, like it improves the local workforce, and digitizes that, and it assimilates reasonably well with existing workflows, existing material workflows, like particularly with concrete and timber framing on the island. And it's easier to assimilate with existing legislation, and somewhat easier to avoid some importation duties and delays, and particularly in this COVID time. And so we are hoping to learn like the similar bits on the other side, like what are the learnings and the benefits on the mass timber side, and to the point that like we can then kind of meet up and scale up our efforts in that sense. And we definitely realize that like there are some shared capacities on either side, like the idea that there's a design IP, and then there's a kit of parts, and then there's a software stack, and then there's a kind of some kind of factory arrangement and adaptation, integration with the supply chain. All of this is commonly shared across. And one thing that we do realize that, or we believe, is that user participation is key. And regardless of which side it is, that we should consider direct to consumer as much as possible. Like, so get the end user involved as early as possible, rather than as late as possible. And so that's one of our key learnings that we want to incorporate in our next projects. So just to summarize, so we started this journey kind of from the point of view of architectural geometry, and we found that this approach, it's easier to engage a broader audience, like a non-expert audience, and it's relatively easy to reason with, and it's definitely easy to compute, and it's also relatively easy to build easy CAD tools. And on the scientific side, like it's a lot of historic wisdoms are inherited. It's very entrepreneurship friendly, and also use of geometry in an appropriate sense usually relates to ecological benefits of using less material, and material only where it's needed. So you're developing shapes appropriate to what the material wants, appropriate to material behavior, etc. And the second thing that we learned is that you know, we definitely want to go from architectural geometry to incorporate on a larger scale the ideas of DFMA and scale from digital timber to mass timber. And in this, we are definitely reminded that as much as we were trying to learn from the automotive industry and on the production side, like how to scale production, like we also want to remember that one of the greatest successes of the automotive industry is that they positioned the car as integral to lifestyle. It was not only a thing of high performance, but like it was an aesthetic of high performance, and it became a socially integrated, and it became part of the lifestyle choices and aspirational aspects for the large part of the 20th century. So, and in this sense, like we definitely want to learn from seminal design team of like Ray and Charles Eames, who had already thought of this when they did their case study houses, that we need to consider vocabulary of materials and techniques. We need to understand like social aspects, and then we definitely need to understand systems of mass production or economies of scale. And this was, you know, strangely, like already from the 1960s when the case study houses of Los Angeles were developed. So with that, I will end here with a little video and then take any questions. Thank you very much for your attention.
Thanks, Shajay. We're watching the video, then we'll read off some of the questions.
Yeah, no worries. Yeah, so this is like ongoing like exploratory work that we're doing with students at the graduate students at the AA DRL. You know, how to provide some easy tools and get users to participate in the development of their neighborhood, etc. Whilst also providing early feedback on how much things cost, etc., like how it may be produced. So looking at a social use case for all the industrial manufacturing tool technologies that are becoming available.
Yeah, read off. Yeah, yeah, read off a couple questions. One, John Padilla, more than a question. All the work you do is fascinating.
Okay.
And then another one is, how much of the wood you show is structural versus decorative?
Yeah, I think that's a great question. Like, so what we hope to do always is with approaching it from a geometry perspective is to integrate structural use of timber and structural use of material in general and create shapes in as a at the intersection of structurally viable and useful and also manufacturing wise possible, right? Like, so that's where we want to that's the intersection where we want to operate at, and like all the tool development and all the research development is focused on that singular topic is how do we create new expressions, new shapes, which are structurally relevant and precise and use as little material as possible. So-called strength through geometry, and also physically possible to make. And so that's been our approach with architectural geometry in general, is create novel shapes, but nonetheless that are high performance from a fabrication perspective or a structural perspective. So we definitely don't want to use timber in or any material in a decorative sense. Whilst of course, like in the early stages of exploring shape, like we might not be able to fully guarantee constructability, or like, you know, there's a bit of blue sky thinking going on like early on, but like starting from that, like we try to rationalize and like kind of come at it from the other end as well with our research, the scientific research side. Yeah.
Another question from Frank Weeks. I'd personally love to see a lot of the wisdom that's been gained in these developments to trickle down into everyday life, education, design, construction, etc. How do you foresee this happening?
Yeah, no, I mean, that's definitely one of our main interests is to, you know, use this kind of to recreate some of the ecosystem that like was around in pre, you know, in the early part of the master builder phase, right? Like the 19th century, etc. Like there was definitely an ecosystem built around geometry and you know, that understanding of it, education of it, like, and practical use of it in the making of drawings and like, you know, construction aspects, etc. Like, so we want to try and use computational technologies in that way, like use the computer and these gamified interfaces, etc., to make it more, let's say, widely resonating, and so we want to play our part in it. Like, of course, like, you know, the fabricators and engineers and others like also have to and are doing, like some of the leading engineers are kind of engaging with this idea of how to promote design and in specification of timber in early phases of design, because for the large part, like, at least in our experience in Zaha, like hardly designers know how to design for timber, and then engineers most often than not like wouldn't specify timber because there are no easy tools, no easy handbooks, etc. And then also, like, places like Finland, except like where we're working with Metsä Wood for a while, they suggest that timber carpentry skills are like kind of evaporating because there's no vocational schools and so on. So, but we see, like, robotic manufacturing, digital manufacturing as a vehicle to address that, because there's a lot of young people interested in timber, precisely because of its digitized nature, because of its amenable to robots and other digital machinery. And so we see digitization as a key part of sustainability, both material sustainability, but also the social knowledge sustainability. Like, how do you have to retain the ecosystem, otherwise you're not, and nurture it, otherwise we're not going to be able to build. And yeah, so that's so we, in answer to your question, I would say, like, digitization is our key first step.
Here's another question. I hear many references to you figuring out how to draw things in design. What about the transition to purely digital design and eliminating drawings?
Yeah, when I say draw things, I mean in 3D. Like, our design processes are digitally native. Like, our conceptual thinking also happens directly on 3D software, and so it's not that, like, we draw it by hand on Sketch It and then, or make physical models and then recreate them on the computer. We Yeah, we use geometry creation tools, like, in our digital platforms, and to that end, like, we use a lot of non-standard software, like particularly Maya, which is like not meant for CAD work at all. It is meant for computer graphics and other intuitive modeling, intuitive shape making. And we found that by making small changes to it and incorporating a lot of advances in the science of geometry creation into Maya, like, we can definitely enhance that creation process with some fabrication information or structural information. So that's our attempt, is to create modeling procedures, like steps on how to start with, like, a cube, and like what are the operations you can do to create something that is 80% there. Like, so particularly something like this, like, how we can start with, and you can go from, like, left to right in a matter of less than a minute. Right. So then that makes it very, very intuitive. Like, so we can handle a large amount of complexity in this way. And not to say that the thing on the right is, like, perfectly fabricatable or perfectly structurally working, but it's a fast process. Like, you go between this and some feedback. And then you work with engineers at a later point, where things are at least reasonably in first principle, working to the right right strategy, at least. Yeah.
Thank you. A question from Alexandra Lee. Many of your projects are very fluid and sculptural, and the geometry seems to lend itself to concrete and steel as materials. Do you see mass timber as limiting this expression, or do you think a new language is emerging from working with this new material?
Yeah, definitely. Our interest is to work and evolve a new language, and that's why we are also looking at historic uh, uses of, like curved geometry. I mean, we are definitely interested in curved geometries. Why? Because curvature is structurally beneficial. And if it is structurally beneficial, you're likely to use less of it, less material. And currently, like, creation of curved geometries is more expensive, because for 100 years our supply chain is like geared towards like producing straight line things, and that is again because it was geared to steel and so on. And so at the same time, like, we want to evolve a new language that is more suited to timber for sure. As designers, that is our kind of one of our primary motivations, is indeed to explore new tectonics, new languages that we can become proficient at, and so makes our buildings uniquely visually unique, but also unique in the way it will be constructed, unique in the way it will be experienced, etc. So yeah, that is definitely the motivation to collaboratively working with contractors, fabricators, engineers to evolve a new timber specific language in the same way that we have done with other materials like cable nets and so on, like, yeah.
As a comment, those designs are beautiful. At what phase do you start to integrate MEP into your designs? And do you use BIM formats to do so? Also, how do you adjust the designs to meet regionally specific codes, especially with regard to energy efficiency?
Yeah, so we are definitely, I mean, we do integrate MEP uh, and major critical building code, etc., at already in this stage, as I try to kind of gloss over, is like, so like here we are encoding the major rules, right? Like, we are not saying like literally here the pipes, here are the, so we are saying like try to stack all the toilets vertically, so you try and get like the vertical run, and we can also calculate, like, at the early stages, total length of uh, let's say plumbing, or total or fire compartments, fire compartmentalization in the stack level, right? Like, so when we are doing this stack, like, we are trying to see what does the international building code allow, and so on. um, but down the line, like, when things do get more and more engineered, like after, let's say, RIBA stage 2, when we go into RIBA stage 3 already, like, we are incorporating transferring a lot of this information, like from Maya and Rhino into BIM formats. And BIM we mean as a database, so which we then can import into Revit or any other BIM platform. So we do deliver appropriate LOD BIM, but we consider all the rules at the design phase. Structural rules, MEP rules, HVAC rules, fire rules, and but like the critical rules, right? And then the detail engineering starts after the users have made their choice. So and now we are in the phase of detail engineering of this particular project. Yeah. I hope that answers your question.
Sorry, I was on mute. Here's a question from Frank Weeks. Is mass timber tooling flexible enough and evolving quickly enough to keep up with the computational advances? Or do we continually find ourselves designing to what can be built with existing tools?
I think, like, I don't know much about the mass timber tooling side, but like the little I know, like from like looking at Katera and side factory OS or other things, and primarily speaking to Greg and other fabricators in Bloomer, Lehman, etc. Like, um, our belief is that like we as designers like shouldn't be designing with the fabricators tools, right? Like that we should incorporate the constraints in our design platforms. So that's the major principle strategy of architectural geometry, is that you incorporate the constraints of like the length of timber or the size of timber or like tooling angles or amount of joints or like, you know, or the kind of lapping or like various other things, like incorporate those constraints in the platform of choice, like the design platform of choice. And that's where we are learning a lot from like this kind of historic way, of this. This is not like incorporating all the structural tools, like, but it is just incorporating the major structural constraints and behavior that the center line has to pass through the middle of like the stones. So similarly, there are many other tools like rules that we can engage at the geometric level, and that's at least our way of thinking about any manufacturing system, is to engage with the constraints, encode them in our platform as geometric constraints. Like here, the structural constraints are incorporated as geometric rules, that these lines have to be perpendicular, or these angles have to be a certain, they have to add up to 360, or like these kind of things. And we found that if we follow these kind of rules, like then it's easier to translate them to the fabricator's model, it's easier to translate them to the engineer's model, etc. So that's definitely how we plan to work with the mass timber tooling. Not ahead of time constrain ourselves with like all the details, which is what this is suggesting here, that like we should only design with these kit of parts. Like, well, no, we don't want to do that. We want to incorporate the main constraints such that it is fabricatable.
Yeah, I have a question, Shajay. I mean, it's just amazing how many different countries your firm is delivering very, very complex geometry, and then you have to coordinate with supply chains all over the world. And then you're continuing to explore DFMA, and now adding to that or bringing more into mass timber. It's just, I don't know how you do it without, no matter how many people you have on your firm, because it's global and with every kind of material and all of the different regulatory environments. So I'm really happy you're finding time to even dig more deeply into DFMA for mass timber.
Yeah, no, I think like, I mean, in our experience, I mean, yeah, like in China or in the Middle East, or like, I mean, we don't have that much experience in and foothold in the US, unfortunately. But we do think that like the vehicle for a lot of these things is a aspirational design, right? Like that, the first ones will be, you have to create like that engaging carrot that many people can participate in, and then they can find some ownership and interest and so on. So while we make these, like, we know it is not 100% fabricatable, like, but we know we are roughly in the ballpark. But at the same time, it is an aspirational set of images and design and spaces and so on. And that creates the initial momentum, and then like we later we have the expertise and mostly we have the network to solve like the details and the peculiarities, because regardless of economy, which economy, people like solving problems. Like that's what we know, and so we want to create engaging enough problems, let's say, and socially useful problems, right? Like something that is that people want to invest effort into, and that is beneficial to society. And so it's not flimsy, but it is sufficiently challenging that like people can engage and create these things. So like and as I said, like, you know, these buildings were realized in 2019 and the airport was built in 4 years. But like the challenging problems were created already 10 years ago during Beijing Olympics. So I think, yeah, so that is, at least that's the key to our motivation and our engagement with like all of the people, is that we create engaging spaces and compartmentalize them to be solved. Like there are enough interesting problem solving aspects to it. Yeah.
Well, I certainly hope you enter as aggressively as possible the US market, both for project platforms like your project in the island off of Honduras, as well as these stadiums or any very large commercial buildings. Hope to see that
Yeah, we
happen.
certainly hope so. And like, we hope that, you know, regardless of whether you're a small, medium, large business, like, you know, we want to engage with since people genuinely interested in this industry, right? Yeah.
And what could I guess, to kind of close, what would you recommend people interested in these same kinds of integrations that you're working with? You're working on your PhD at ETH. You're involved in projects all over the world. How do people keep kind of track with what Zaha Hadid is doing and your kind of research? What would you recommend for people who share these interests?
Yeah, I mean, people who share the interest, like, I think, you know, like the main platforms is to, you know, events like March Madness, and other, and then ETH is definitely one of the kind of centers for research side of things, like the scientific research. And at the AA DRL, like, is where we are nurturing the next generation of talented designers to work on all these opportunities and problems of the 21st century, right? That it's not only material, it is also social, it's also economical, etc. So there are many layers to architectural problem solving. So we've been invested for the last 20 years at the Design Research Lab for that reason. And Zaha Hadid Architects, like the Instagram feed, we have our Instagram, Zaha Code Instagram. Yeah, so, you know, we and LinkedIn and like more and Twitter. So we are engaged in like social media because we want to be as broadly reachable as possible. Yeah, and we engaged in a lot of workshops, like in conferences and so on, like, even though it like really kills us effort wise, we still do at least 2 or 3 workshops like this one we did in Beijing, and some others that we do in universities, like this one we did in India. Sometimes we do it in Mexico, and this one we did in Zurich, and so on. Yeah, so social media is like place to find us, and then you can chase up that links into LinkedIn or other research places.
Well, thank you, Shajay. We'll be talking about that topic also tomorrow with our panel, because I think there's growing interest in people wanting to connect with people with this shared interest, and where are the platforms, where are the events, and how do we do that online? But thank you very much for your time, and I hope we can do some projects here in the US as well.
Yeah, I look forward to that. Thanks so much.
Thank you again. Thank you, audience.